Today we'll be going through a quick tutorial for processing photogrammetry data from the Zenmuse P1 in DJI Terra. DJI Terra is a highly versatile program, able to plan flights, display live data recording, and process photogrammetry and LiDAR data. We will soon be releasing a tutorial for processing LiDAR data through DJI Terra, so make sure you subscribe to not miss out on that. First off, to install DJI Terra, download the file from the DJI website. Once downloaded, run the setup and follow the steps, allowing it to be installed on your computer. Open the application and you will be greeted by the home screen. First, sign in with your DJI account and activate your license with the activation code, if not done so already. Then select New Mission, and in the pop-up window, either 2D Map, which produces an ortho photo and DSM, or 3D Model, which produces a 3D mesh, and give the mission a suitable name. The photos can then be imported either by selecting individual photos or the folder that they are stored in. The initial camera positions will show on the screen and the individual photos are listed on the right-hand side. The map type can also be changed here if necessary. Select the most relevant mapping scene. For 3D model type, the setting Normal can be applied for most scenarios. Circle is ideal for the reconstruction of small and vertical objects such as towers or base stations, and Power Lines is of course suitable for power line reconstruction. The resolution can be set. The choice here will depend on your quality requirements and time constraints. The arbitrary coordinate system will take the projected WGS84 datum for the area in which the photos were captured, but a different output coordinate system can be chosen if desired. The default elevation will take the ellipsoidal height, however, geoidal heights can also be chosen. If ground control points, or GCPs for short, were recorded, these can be imported and aligned in GCP management. Once the correct coordinate system that the GCPs were recorded in is selected, import the GCPs using the Import GCP file tool. The GCP data must be in a text file with name and coordinate attributes without headers. The GCP positions will then appear in the viewer. Now the center points of the GCPs can be marked in the photo. This significantly improves the accuracy of the reconstruction and is worth spending some time on if accuracy is important for the project. Click on the first GCP on the list and select Only Display Photos with GCP to show only the photos in which it is visible in the slider at the bottom. Click on the photo and zoom into the GCP. The blue cross shows the initial estimated position of the GCP. Once targeted, click the center point of the GCP to mark it. Marking the center points and applying the alignment should move the blue cross towards the visible center point of the GCP. Repeat this for around 4 to 5 photos for each GCP. Then, the initial alignment can be started by selecting Aero Triangulation at the bottom. This will take a few minutes or more depending on the size of the project. Once complete, the sparse point cloud will be displayed. Inspect the alignment by going through the photos and checking the position of the blue cross. If necessary, remark the center points and select Optimize to improve the accuracy of the reconstruction. Re-optimization can be carried out as many times as needed. The data is ready for reconstruction once the blue cross is accurately positioned over the center point on all clear photos. The reprojection error, as shown on the right-hand side, should ideally be below 1 pixel. Once complete, select around 1/3 of GCPs to act as checkpoints by changing the type under the list of GCPs on the right, which will provide an independent measure of absolute accuracy. Finally, you can select Start Reconstruction, which will generate your chosen products, i.e. 3D mesh or orthomosaic. This will usually take around half an hour to a few hours depending on the size of the project and the settings applied. Once the reconstruction is finished, the output product is displayed in the viewer and can be inspected. Back at the main screen in DJI Terra, the products can be exported to be shared or post-processed in your desired software. Annotations, point coordinates and length, area and volume measurements can be made, saved and exported. Select Quality Report at the bottom to see key statistics for the reconstruction, such as error of the GCPs and checkpoints, and camera calibration information. If an orthophoto was generated, the report also displays a DSM and image overlap analysis, GSD, coverage area, and average flight altitude. So that's it for this tutorial. I hope this has provided you with a clear understanding of the photogrammetry processing in DJI Terra. To not miss out on our future videos, including tutorials, reviews, and industry insights, hit the subscribe button, and don't forget to leave us a like or drop us a comment if there's any further questions that you have. Thanks very much for watching, and see you next time.